Alright, hello again. In this video we're going to be solving logarithmic equations. This is part one because what we're going to be doing here is we're going to be doing single logarithms. Later on we're going to do multiple logarithms in the same equation. That'll be in part two. So in this part we have a single logarithm, log base 5 of 2x minus 1 equals 3. The first step in solving a single logarithm is to rewrite. So in this one we're going to rewrite it in exponential form. So we're going to rewrite it in exponential form. Base 5, exponent, log is always equal to the exponent, so it's 5 to the third equals 2x minus 1. So this is exponential form, 2x minus 1. Alright, so then we're going to solve for x. So we're going to take this and we're going to raise it to the third power and get 125 equals 2x minus 1. We add 1, we get 126 equals 2x. We divide by 2 and we get x equals 63. So my answer here is 63 for x. And in general, solve a logarithmic equation, what we would do is first isolate the logarithm, second rewrite it in exponential form, and third solve for the variable, and fourth check your solution. So in this example, log base 3 of 2x plus 5 minus 1 equals 3 is our beginning problem. We are then going to first isolate the logarithm. So the first thing we would do here is add the 1 on both sides here, so that we have the logarithm with base 3 of 2x plus 5 equaling 4. Now we rewrite it in exponential form. So here's our base, here's our exponent, 3 to the fourth, so we're rewriting. So 3 to the fourth equals 2x plus 5. Now we're going to solve. So we're in our third step here, solving. So this is going to be 81 equals 2x plus 5. We subtract 5 from 81 and we get 76 equals 2x. And then we divide by 2 and we get 38. 38 is our answer. So let's just check 38 to make sure it works. So if we do that, we would do the log base 3 of 38 times 2 plus 5 minus 1 equals 3. We multiply this out, we would get 76 plus 5, so we get log base 3 of 81 minus 1 equals 3. Now remember, a logarithm is the exponent, so this is asking us what exponent do we make 3 to what exponent is 81. So this value here is actually 4. It's the exponent on the 3. So 4 minus 1 equals 3. That does work. So we did pick the right answer there, or we have the correct solution, I mean. Alright, now the second example I can use this for is when I want to find an x-intercept for a graph. Now we graphed this in the previous video. We graphed this and we had the x-intercept for this, but let's try solving this using this method to help us find the x-intercept without graphing. So to do the x-intercept, what we would have to do for an x-intercept is, that means y equals 0 here, so we would plug in 0 for f of x, and we would solve this logarithm as it was equals 0. So the first step is to isolate the logarithm, so we would add 2 to both sides. So we get 2 equals log base 2 of x minus 3. All right, then we rewrite our equation. So rewrite. So base exponent, well, they're the same here, so 2 squared equals x minus 3. So that'd be 4 equals x minus 3. So x is 7. So we can recall that our intercept was 7, 0 from the previous video. But in this case, we were able to find the x-intercept using this method without graphing. All right, my third and final example in this problem set in this video is a different logarithm, or one of our standard logarithms. This is the ln. So when we're doing this, it's already been isolated, so we don't need to isolate. We go on to step 2, which is rewriting. So in the rewrite, we have to look at what the base is here. So here the base is e, so we're going to have e to the second equals 3x minus 1. That's going to be our rewrite on this one. So we have e to the second plus 1 equals 3x, and then x is going to be e to the second plus 1 divided by 3. So this is our exact value. If we want to use our calculator to estimate what that is, we would first turn it on, and then we go e, so that would be second e to the second plus 1, get an answer, and divide by 3. So our answer is about 2.796 to 3 decimal places, about that. But this is the exact answer, and this might be what they type in the book. So, and put it in the book, and it might be written, if they write it in one line, it would be e squared plus 1 in parentheses divided by 3, like that, if it's written in one line. So in this evaluation, we had a standard base that wasn't written, so we have to know what that is and convert. And then we'd have to do that also if it just said log, then it would be 10 to the second instead of base e. So if we see log of something, so if we were doing the same exact problem but we had log with no base there, then this base would be 10. So this problem would change a little bit. It would be 10 to the second equals 3x minus 1, and we'd solve it the same way as we solve this one. Add 1, divide by 3. Alright, so that's solving part 1 of solving logarithmic equations. And the 4 steps are here: isolate, rewrite, solve, and check.